Problem. We have an inelastic collision where you are sitting in your car and a truck drives up behind you, rear ends your car, and the two of you move off as one large object after the collision. We know initially the truck is going 12 meters per second, we know the car is not moving at all, and we do not know the speed after the collision, and that's what we are trying to find. This is a conservation of momentum problem. We know that the momentum of the truck plus the momentum of the car before any collision happens has to equal the momentum of the truck plus the momentum of the car after the collision. So PT plus PC equals PT prime plus PC prime. What we can do here is we can expand each of these momentum symbols into mass of truck times velocity of truck plus mass of car times velocity of car, and that's going to equal mass of truck times velocity of truck prime plus mass of car times velocity of car prime. What I'm going to do now is I'm going to cross out any of the variables that are zero, make my life a little bit easier. I know that the velocity of the car before the collision is going to be zero, so I know that the car has no momentum, so I can just get rid of that, make my algebra just a little bit easier. So I have mass of truck, velocity of truck equals mass of truck times velocity of truck prime plus mass of car times velocity of car prime. Now, one thing that we do know is that since they move off together, the velocity of the truck and the velocity of the car prime, both of those after the collision, are going to be the same. We don't know what they are, but we know that they're going to be the same. So what I'm going to do is rewrite my equation slightly. The left side is going to remain unchanged, and on the right, I'm going to leave mass of the truck, but instead of saying times the velocity of the truck prime, I'm just going to say times velocity prime, because the velocity of the truck and the car are exactly the same. So I can do that with the car as well. Mass of the car times velocity prime. That way it's obvious we're working with one speed variable and not two. So now our job is to try and find what this velocity is. We have all the other variables. We know what those numbers are. So we just have a little bit of algebra, plug them into the calculator, and then we're done. So left side of the equation is going to stay the same. Mass of truck times velocity of truck. On this right side, I have two terms. They both have velocity in it. So I'm going to take velocity prime out. I factored it out. And that leaves me with mass of truck plus mass of car. One more step, I just have to divide the two masses to the other side, and my algebra is finished. So I have mass of truck times velocity of truck divided by mass of truck plus mass of car. So I can plug those numbers in. I'll do that over here on this right side. The mass of the truck is 650 kilograms. And the initial speed of the truck was 12 meters per second. And in the denominator, I have 650 kilograms for the mass of the truck plus 400 kilograms for the mass of the car. And when I plug that into my calculator, I should get that the speed of the two vehicles moving off together is 7.4 meters per second.